This is my video about my favorite sensation and perception thing, and I did it on hearing and the structure of the ear between human and dogs. What is the definition of hearing in the process? Hearing is the process of perceiving sound. The process includes sound waves entering the ear as vibrations hit the ear. The outer ear, pinna, collects the sound waves. Sorry if I pronounce anything wrong. The middle ear amplifies vibrations using the ossicles, which are three tiny bones called the malleus, hammer, incus, anvil, and stirrup. The inner ear, cochlear, transduces vibrations into neural signals. These signals travel through the auditory nerve to the brain. The brain organizes and interprets the signals as meaningful sounds such as speech, music, and environmental noise, or noise my dog hears that she just barks at randomly. Okay, so one thing that we really do need to take into consideration between the two is the difference between the structure of a dog's ear and a human's ear, and why we might be hearing things differently compared to ear. So first, we should look at the outer ear, the shape, mobility, function, and covering, which covering is just like what's protecting the ear or what's covering like the skin, the fur, and stuff, but I'll get more into that. So the shape for a human is a consistent, small, round shape that's connected to our head. So it's so small in our muscles, there are only about 11 of them, so it's harder to move our ears compared to dogs that are longer. So it depends on breed if it's floppy, stood up straight, but all dog ears are funnel shaped to help them just raise their ears if they need to move in certain directions. So that brings us to mobility. So for a human, again, a human ear has around 11 muscles in the ear. And then even though that seems like a lot to like many people, it is attached to our skin, and so it makes it harder to move. But for a dog, it's easy to move around with over 18 muscles in the ear, and it allows independent movement from side to side when they're trying to detect where the sound is coming from and pinpointing just exactly where that sound is. The function is the human ear helps collect sound, but offers minor directional cues, so we can't really determine maybe where a sound's coming from compared to a dog, whose sound waves are more effectively directed toward the ear canal and plays a role in canine nonverbal communication, so it helps dogs pinpoint maybe the sound is if they're in danger more than a human can when the ear can't fully move around in movement. And then covering of the ear is just the human is covered in skin, is not really protected, so there might be more bacteria, but a dog is just covered in fur, so it helps protect the ear better from the debris and bacteria. So now we should look in the middle and inner ear. So first I'm going to look at the ear canal. So for a human, our ears are straight and direct ear. It's short, it doesn't have a shape, but it allows for better drainage and overflow leading to less infection risk, because dogs' ears are so big that it's really hard. So a dog's ear is L-shaped, which is either vertical, horizontal, depending on the dog breed, and is longer and narrow. Because of the L shape, the infection can just last in their ear, so it's harder for them for drainage to come out. Next is the auditory ossicle. So for humans, it provides less amplification because of just how tiny the ear is compared to dogs, and the sensitivity is tuned for speech frequencies instead of maybe a whistle like a dog. So for dogs, it provides great leverage and stronger magnifications of sound vibrations. So that's why dogs can hear better and farther sound vibrations and frequencies compared to a human. So for the thympical cavity and the thympical bulla, dogs have thympical bullus, but humans do not, and it's part of their temporal bone in dogs. It's the middle ear cavity, which includes air spaces and the bones that transmit sounds for animals. Humans do not have these, but humans do have tympic cavities that is relatively large that provides difference in hearing range and sound sensitivity, but dogs still have a bigger sound sensitivity than humans. And then the cochlear and the basilar membrane, again, sorry if I'm saying this wrong, but the basilar membrane has a different distribution of hair cells, which likely represents more specialized or less sensitive auditory system compared to a dog, because a dog has a larger basilar membrane and more sensory hair cells, allowing for a wider frequency and detecting quieter sounds. So these are examples. This is Irma on the left, Mooney in the middle, and then Max on the right. And it's just examples of like how ears are different on dogs. So this it mostly is common that maybe everyone knows is this is a higher frequency that dogs can hear compared to humans, and then the lower frequency. So dogs are able to hear higher frequencies around 40,000 hertz, and humans hear frequencies about 20,000 hertz. And then higher frequencies are encoded at the base of the coccyx, and lower frequencies are encoded at the apex. And then the absolute threshold, dogs have lower absolute thresholds for higher frequency sounds than humans. And then humans require the same frequency to be much louder when a dog hears. And then because of their large ears, it's in higher anterior cells, it helps detect higher frequencies. So yeah, that was my favorite thing, and the difference between hearing for dogs and the structure of their bones, their ear bones, for dogs and humans.